हेलो स्टूडेंट्स आज जो हम आपके लिए टॉपिक लेके आए हैं वो है क्लास 10 का ही चैप्टर 1 का है कि किसी भी पॉजिटिव ऑड इंटीजर को हमको इस फॉर्म में रिप्रेजेंट करना है. So we need to show that any positive odd integer should be in the form of 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer, right? So first of all we want to discuss some basics. Basics are that we need to take any odd integer and that we need to put it in the form of this bq plus r. देखिए a is the dividend here, right? A is dividend here, B is divisor here, okay, and Q is quotient, and R is remainder. Okay. Now this thing is clear. Now there's one more thing to look into. It is that remainder should always be less than B. Means the remainder should be always less than the divisor. If it is equal to the divisor, then the multiple will increase, number of times will increase, and when it is more than divisor, then also the multiple, the number of times will increase in the division. So it should be, the remainder should always be less than divisor, right? इसके लिए we have the equation is this, that 0 need to equal or less than remainder and it should be less than divisor. So this is the condition here for every one of them. So let's start with the sum now, right? तो actually इसका एक base होता है, base on which this situation of the question, condition of the question is based. It is that what is the remainder now? What is the remainder? Remainder here is 1, 3 and 5, right? And the divisor is 6q here. Okay. If the divisor is 6q, I must tell you one thing. The divisor is 6q. It means that the divisor is 6 here and q is the quotient and plus this is the remainder. So divisor is 6 here. If the divisor is 6, then remainder will always be less than 6. So which means that the remainder will be always maybe equal to 5, right? So we can take it here, every condition. Now first of all the condition comes that if r is equal to 0, now here r is equal to 0. Now we don't know what are the odd numbers, right? We will just transform them, take some integers, transform them in this form and then sort it out that what is even and what is odd. So this is the structure of the sum, right? This is the mapping of the sum. So we will take first condition, r is equal to 0. Now if r is equal to 0, then it is 6q, right? Because 6q plus r is equal to 6q. If r is 0 here, so r is 0 here, so it's no use writing it here. So this is 6q, and 6q is again, we will take it as 3q, right? 3q plus 0 also you can write, but there's no need. So now here it is 2m, where 3q is equal to m, right? So we got the structure here as 2m, right? Now this was the first condition in which we took remainder as 0. Now what, according to the second condition, now remainder is equal to, we need to take all the remainders, right? Less than the divisor, okay? We cannot cross the limit of the divisor, so it should be always less than the divisor. So let's take this. Now remainder is 1 here, so it is 6q plus remainder, which is 1. So let's put it again in this form. Let's take the common 2, because for even we need to take it in the form of multiple of 2, right? Okay, so this is q, 3q here, right? And plus 1. Now this is equal to 2m plus 1. Again the same thing, where 3q is equal to m. Is this clear? Okay. Now we have proved this one is equal to this one, right? Now let's take the third condition. If r is equal to 2, then what? Okay. Now if r is equal to 2, the 6q plus 2. Okay. Now let's take the common 2 here, and then it will be 3q plus 1, right? 6q and plus 2. So it is 3q plus 1, and this is 2m, where 3q plus 1 is equal to m, right? Now we have taken hold of this 3q plus 1 as m, so it is 2m. Okay. Now we have done three conditions. Now next condition is r is equal to 3. Now if r is equal to 3, then it will be 6q plus 3. Okay. Now what will happen here? Now let's do this. Okay, 6q plus 2 plus 1. We're gonna split this 3 because we need common 2 here like this. Alright. So it is, let's take common out of these two. So 2, 3q plus 1 is equal to 2m plus 1. Now this is equal to m, so we can write here where 3q plus 1 is equal to m. Now I hope this thing is clear till here. Now we are going to take the next condition. Now what is the next condition? If r is equal to 4, then what? Okay, it is 6q plus 4, right? Because remainder is 4 here, so we can take it like this. So 6q plus what is this 4 now? We can take it as 4 only, because it is a multiple of 2. So let's take common 2 here, and it is 3q plus 2. Okay. Now it is 2m, right? Where 3q plus 2 equal to m. Fine. I think this is very clear. Okay, 3q plus 2, we have taken it as m, so it is 2m, right? Now there's a less space, so we are going to raise the upper two conditions. Now let's take the next condition. What is it? Now if we have taken the remainder till 4, right? Now if remainder is equal to 5, then what? Then the condition will be here like this. Now we need to again to split it like 4 plus 1, you must say 4 plus 1, right? And this is, let's take the common here. It's 3q plus 2 plus 1 is equal to 2m plus 1, where 3q plus 2 is equal to m. So we have taken this as m, so it is 2m plus 1, right? Okay. Now we are clear with the all the conditions, right? Now what we have got till now, you see, you can very well see that we have taken different conditions. So r is equal to 0, we got it even. R is equal to 1, we got it odd, and r is equal to 2, we got it again, even. And r is equal to 3, when we took r remainder equal to 3, then it was 2m plus 1. And when we took r equal to 4, we got it 2m, right? And when we take remainder as 5, then also we got this 2m plus 1. So now what is the conclusion finally? We have solved the sum, but we need to write some conclusion here. Conclusion is this, that whatever is the multiple of 2, whatever is the multiple of 2. Now let's take 6q was 2m, 6q plus 2 was also 2m, 6q plus 4 was also 2m, right? So all these are even, right? All these are even. Now how these are even? Because they are the multiples of 2. Fine. Now on the other hand, what we got? We got 6q plus 1 6q plus 3 and 6q plus 5, they were all of the form of 2m plus 1, 2m plus 1, 2m plus 1, right? Okay, so all these were all or odd as it was added by 1 to an even number. Okay, now it is very clear. Now this is even and we are adding 1, this is even, we are adding 1, this is even, we are adding 1. So these all are these all are odd numbers, right? So these are not even and these are even. So it is very clear. So at the end we can say that, so 6q plus 1, 6q plus 3. Okay, sorry, we need to write a conclusion that only. Hence any positive odd integer is of the form of 6q plus 1, 6q plus 3 or 6q plus 5. That's it. So this is the final conclusion. I hope you have understood this, and if still there is some confusions, then you can call me up or comment in the comment box. I will respond to you. Thank you.